All right, I'd like to give you a brief overview of theory constraints. There's one paragraph in your textbook about theory constraints, but let me try to talk to that a little bit. Yeah, theory constraints is really pretty straightforward. It's very simple, and the idea is there's a bottleneck in every single process, and the totality of the output of the process is equivalent to or equal to the output of the bottleneck. Yeah, I want you to remember or think back to a time when you're driving up the freeway and somebody, I don't know whether it could have been, this is California, 45 minutes ago, put their brakes on in a particular point in the road, and there's a lag. Everybody slows down at that point until at some point, again in California, a couple of hours later, that that point actually now clears out and traffic begins to flow at a constant pace. You see that you have a string or a row or a line of people hiking. As one person slows down in a particular spot, the entire rest of the line will slow down at that same point. Um, that's that's one type of example of a bottleneck. Now, if we have a group of machines, well, let's think about this. Let's think about like manufacturing, if you will, a Chipotle burrito. You have multiple stations manned by multiple workers, right? And you go to station number one, and they tell you, or they steam your burrito shell. Move to station number two, they put some rice in your burrito. Station number three, they put some beans in your burrito. Station number four, they put some then cheese and produce, and then they wrap it up uh, tortilla, and then or the shell, and then they package it. Well, in that particular instance, it's that last station where we're putting cheese and produce, and the customer's got to make a variety of decisions about this, and then we've got the extra packaging to do, and then off to the cash transaction. It's that point where the process takes the longest, right? So maybe it takes 15, we'll say 15 seconds to steam the burrito, 15 seconds, or even 10 seconds to put rice on, 10 seconds to put the beans on, but 25 seconds to do all this other, again, produce and cheese, etc. We can only make one burrito every 25 seconds. So it doesn't matter how how many tortilla shells we get steamed, filled with rice, filled with beans, and shoved off into the process. Only one burrito every 25 seconds can exit that process. So it's that it's that point that it's a bottleneck. And this is what the theory of constraints is all about. It's all about identifying where those bottlenecks are. And by the way, we can find them by looking for inventory that's piled up in front of the process, um, or in front of the operational step, and then finding ways to either reduce the setup time of that operation or maybe divide. In this particular case, maybe they should have another worker, and that other worker should put the cheese on, somebody else should put the produce on, or maybe whoever puts the beans on can also put the cheese on, and we begin to balance out or reduce the amount of load on that bottleneck. This is what the theory of constraints is all about. And there's a couple of principles. One, never run bad parts through the bottleneck. Two, never starve the bottleneck at parts. So always make sure that there's parts ready for it to run. If we can find an alternative route through the factory that doesn't require using the bottleneck, we should do that. Because theory constraints says the only measure of manufacturing that matters is the dollars that are generated by the plant. So the parts that exit the plant are turned into dollars when customers buy them. That's the only meaningful measure of performance for those that practice theory of constraints. So that's really the big idea in theory of constraints. You can make a significant improvement, many improvements in operations, looking for that bottleneck, correcting the bottleneck, improving the bottleneck, improving the flow through the process. And in doing so, again, we create more even flow. So we have swifter, even flow. Again, the velocity of materials again stabilizes and accelerates through the production process.